Hello viewers, this is Kisi and welcome back to my channel. In part 4B of my tutorial series working with step 7, I will show you how to program star delta in OB1. Let's get started. So now we will look at star delta diagram and then give a brief explanation before we move on to our schematic manager to do our program. Okay, so I have this diagram here right from instrumentationblog.com. Okay. So the concept behind star delta starters is that we need to start a motor, but we need to reduce the starting current of the motor. So to do this, star delta deploys to a simple solution, and then the solution is that we need to start the motor in star, which means when motors are mostly connected in star, their startup current is a bit low. So running it in star will start with a very low current, and then after a time interval it switches to delta. At that point the motor can then run at its full speed. So let's look at the power circuits of this particular arrangement. We have all the 6 leads of the motor coming out, and then we have the contactor arrangement right here. So we have the main contactor, which always pick to bring power directly to one section of the windings. And then we have the delta and then the star contactor on the other side of the windings. So during the startup, delta always picks alongside with main contactor, and then after a period or after a preset time, which is determined by at what point would the transient current of the motor die out. So that will give you or inform you how long you should set your changeover time. So when that preset time is reached, then star is taken out of circuit and then delta takes over. And at this point, the motor can run at its full speed. Let's look at the control drawing. So from here we have the breaker, we have the safety switch, we have overload, we have stop push button, and then the start. We have the main contactor which holds itself on after starting, and then we have the star and then the delta contactor. So during startup, main and star contactor will pick, and then this timer will also start counting. When the preset time elapses, then the timer will energize, which means it will open this section of the line, and then the star contactor will drop, then also close this section of the circuit to bring in the delta contact. So now with this explanation, let's move on and have a look at PLC wiring arrangement. So right here we have the arrangement. Here we have our start, push button, stop. We have the safety switch here, right here, overload, and then the miniature circuit breaker contact also here. So we'll be monitoring all these inputs, and then the output we have the main contactor, we have the delta, and then star contactor. So with everything set right here, we can then move on to our step 7 program to start our code. Okay, so I've already opened our getting started program, and then I can open OB1. But before then, I will take you to the symbolic table. Okay, to open the symbolic table, you go to S7, and then the symbolic table is right here. You can double click on it to open. Okay, so the symbolic table is right here, and with this time I've already entered all the input and outputs that we need, but we can cross check quickly. We can see that first we need a start push button. So we are now considering the motor as a motor that is running a pump, so I call it pump start. So we have the pump start, which input is 3.4, pump stop is 3.5, and we can confirm we have 3.4, 5, 6, 7, and then we move to the next byte, which is 4.0, and then the output we have starting from 5.2, 3, and 4. So we have our symbolic address already entered. Okay, so I can minimize this, and then I can also minimize the symbolic table, go back to the block, and then I can open the OB1. Okay, OB1 is open. So we already have our old programs that we have here. I can enter a new network, which is Control R to enter a new network. And then here we can have a star delta implementation right here. Okay, with the good understanding of the circuitry, let's look at some of the things we need to implement this star delta starter. So first we will still need our AND gates, our OR gates, we will still need our latches, and then the next new thing that we will need will be timers. So we can take this advantage to talk about timers. Okay, so if you look on your left side, we have the we have our list there, and then we have our timer. So I can drop it, and then we can see that we have various types of timers, a lot of them. But today we will concentrate on the on delay timer and then the off delay timer. The other ones we will look at them later on. So on delay timer simply means that whenever this timer receives command to start, it will run, so its preset time elapses, and then the output of this timer will come on and then stays on till it is either reset or it loses the input signal. So that's how on delay timers work. So that's why we term them as on delay. So immediately you receive the on signal, it will delay for a time period, a preset time, before coming on. And then off delay timer simply means that whenever it loses the start signal, it then needs to delay for a time period before going off. So it has different applications, and then basically in this Star Delta application, we on delay timer for our application. So with this understanding, let's go ahead and then implement our Star Delta. So normally with this set of problem, what you normally do, you can start from the output section towards the input. So our main item that we need to concentrate on from the drawing will be our main contactor, because the main contactor basically holds or controls most of the items here. So we will bring our main contactor call, and then we will look at some of the conditions that needs to be met before energizing the main contactor. So we will bring the main contactor here, and then from our list, our main contactor is Q5.2. So I'll say Q5.2. Okay, so we have our main contactor. Now with this main contactor, we will then look at the conditions. So at them, all the contacts that you put in front of this particular contactor or any output to before it's energized as conditions. So we will look at some of the conditions that needs to be met before we can energize the main contactor. So with this drawing, we can see that before the main contactor, which is this very one, can energize, which means we need the signal on, the safety switch on, the overload on, the stop push button at close position, and then we press the start push button, which will then bring on the star contactor before the main contactor comes in. Okay, so before this main contactor comes on, condition number 1 will be that our miniature circuit breaker has to be in close position. So we'll bring in our miniature circuit breaker, which when it's off is normally open, closes, then we will get signal. So we'll look at the miniature circuit breaker inputs, which is our ready, which is 3.7. Look at 3.7. Now we look at the next condition. The next condition is that the safety switch must also be in on position, or we can get signal going to the main contact being set in the very one. And then we can see that our one, which is main, is 3.7. 3.7. The next condition, we need the overload, which is 5.4.0. Okay, so our overload also needs to be a condition to be met before our main contactor can energize, or other contactors can energize. Okay, so we look at that overload, and then the next is that we have a pump ready, we have overload. The next one that I would like to put at this section is our stop push button, which is going to 3.5. So our stop push button must also be on before we can send power to the main contact. The next, then we need our start push button, also needs to be pressed before we can send power to the main contact. So start push button 5.4. So we can see all these conditions need to be met before we can energize this. Okay, when we press the start push button, the main contactor comes on, it needs to hose itself on. So we need a latch around the start push button, and then this latch is supposed to come from the main contactor. Just go 5.2. Okay, so we have all these conditions, and then the last condition is that the star contactor must also energize before the main contactor comes on. So we need to put the star contactor contact here, which is Q4. So with this one done, we can analyze it now. We have our stop, we have our start, we have our star contactor MCC ready. Okay, I have two MCC ready here. I have to delete one. And MCC ready. We have the overload. I think the other one that I deleted, which is MCC ready, needs to be the safety switch, which is I3.6, I3.6. All these conditions met, and then we can then close this particular. Okay, so this is our main contactor. Okay, so we insert a new network, and then we can then analyze our star contactor. So we bring the terminal, and then this is going to be Q.4. So that's the star contactor. Okay, so from the star contactor, the timers normally close has to be able to take the star contactor off whenever the time elapses. So it has to be one of the conditions for the star contactor to come on. This is going to be a timer, but remember we've not added the timer yet, so we can leave that the contact active now, and then we look at others that we've already added. We need another condition because the star and delta contactor are having different connection points. They are not supposed to energize at the same time. If you look at our drawing, you can see that the delta and then the star contactor has been interlocked so that we don't energize the star contactor whilst the delta contactor is in circuit, or we don't energize the delta contactor whilst the star contactor is in circuit. So we need to bring that contact. It's going to be a normally closed contact, and then this will come from, this is our star command, so this will come from our delta. Immediately I start typing delta, I think it's easy for us to enter it this way. And then the next condition, so two conditions, the timer, the delta contactor, and then also the main contactor needs to energize. We will need then the start command right here to initialize the star contactor. Pump underscore start. We have our start pump command right here, which is this very one at the top. So immediately the start pump command comes in, and then we will need, just as we did at the top, the main contactor, creating a latch for the star contact. So this is going to be our main command. Okay, so we have our main command here. So immediately we bring the start command, the main contactor picks, it will hold this guy on. So this is our star logic. So we have one item here that we've not fulfilled, that is going to be the timer. So when I'm done with the star analysis, we can add a new network, and then we add the timer. So we can now analyze the timer. Okay, so the main contactor will energize and then needs to bring on, immediately the main contactor energizes, it needs to bring on the timer. So instead of the timer, we say we are making use of the on delay timer, which is this very one. So I click on it. If you want to know help on the timers, you can click on the help, click on any of the timer, and it will give you a breakdown as to how to implement it. So right here you can see that the timer is having a set, which is basically its start command, and then we have the preset time here, and then we have a reset. The reset are mostly not used. You can make use of the reset based on your logic, but in our application I don't think we make use of the reset. Okay, inside the PLC are different various type of timers. They are timers, they are labeled from timeout 0 up to so many of them that we need to check, but because we've not made use of any of the timer here, we can start with timer T1. Okay, so the timer is here. Now you can give the preset time. You need to follow this coding S5 timer S. So if it's 10 seconds, we say 10S. Okay, that is the code how you put in your time delay. So I put in the 10 seconds time delay. Alright, so we are saying that the start command is coming from the main contactor. So this is going to be our main contactor. So we have it right there. Okay, so now we have our timer here, which is T1. We can then make use of this timer contacts in our program. So immediately T1 output comes on, which is the same as it. So an output here will be the same thing what is happening. If you use this timer address, it's exactly as you are making use of the output of the timer. So here, which is the timer normally close contact, that is going to take off the start contact, I'll put the timer name here. So T1. Okay, so I have T1 there, and then I'll add a new network. And then the next network that I'll add is for the delta contactor. So this is our delta logic. Okay, so I'll put the delta code and we'll look at the conditions that needs to be met before the delta contactor picks. So this is delta. Immediately start typing it to give you. Okay. So I come over here, we can see that the delta contactor must also have the interlock that the start contactor is having. So put in a normally closed contact, and this is going to be my start contactor command for an interlock to read. So that is one of it. We need this to interlock it. The next is the timer is supposed to. This is the normally open side of the timer, because whilst the timer is transitioning from close to open, it will be opening the star contactor, and then at the same time, after it energizes, it will then close the delta contactor. So we still use the same timing here. So basically we can see that the timer is also implemented right here. So we can see that for the delta contactor, we need two conditions. One is that the star contactor has dropped, and then the next condition is that the timer has also changed its normally closed contact to normally open, and its normally open contact to normally close. And this section will also be closed. Okay, so with this we can go back and then we analyze our circuit quickly. So we say we have our main contactor here. We are saying that all the protective conditions are on the main contactor way. So it's going to be the main one that will hold the whole circuit on. We have our start push button, and then we have a latch lock across it, which is parallel, which is connected to it to hold it on whenever the main contactor energizes. We determine the current path for the main contact. The next is our star logic. The next is our timer, and then we have our delta logic. Okay, so with our programming done, we can now move to our simulator. Then put the simulator in run mode. Okay, I'll minimize it, and then we can now save and download our program into the simulator. So program is downloaded, we can go online and then monitor our program. Now we need to test the program to see whether all the conditions are right. Okay, so I'll put the simulator at this point. Let me try and put this one right here and then resize the simulator. Alright, so now we have to now look at our condition. Now for simulation, you have to get almost all your conditions right to be able to get the simulation working correctly. Okay, so remember our stop push button is always normally closed, so we need to close it before we start our simulation. It's 3.5. We move to 3.5 and then we close it. It's closed. Now we come to the start command, but this one is a command coming from the start. But now we look at the safety switch. Safety switch needs to be closed, so we need to close the safety switch, which is 3.6. Okay, we come to our breaker. We need to turn our control breaker on, so we turn it, which is 3.7. Now our overload. Remember, every time if the overload is okay, it's closed, and it needs to bring signal to close this section. So we go to, I have to insert a new input. That is, I'll change this one to input 4, and then I can go to 4.0. We also turn that section, so we can see that we have all this section activated now. Now we can then press the start push button. Remember, immediately we press the start push button, we need the start contactor to energize before we can get the delta contactor also energized. So I'll go to 3.4. So this is 3.4 and press the start. Okay, so immediately I press the start, we can see that our main contactor has picked, and then our star contactor has also picked. Now you can see that now the time has elapsed, and then our star contactor has dropped, and let's confirm whether delta contactor has picked. Okay, so which means it did not work correctly. We now go back and then troubleshoot to find out why it did not work correctly. So this is part of the lessons. We need to be able to troubleshoot and know exactly what is happening to our code. Okay, so this section, so I'll try again. So we go, I'll move to this section of our code and then monitor what is happening to our timer. Okay, so I click on start. Timer starts 6 seconds, 5, 4. Okay, So from our troubleshooting, we can realize that the main contactor is not holding on, and because we've placed the star contactor at the wrong position. So whenever the star contactor goes off for the delta contactor to come in, it takes off the main contactor as well, which will in turn reset our timer. So we can see at this point that the star contactor connection point is not correct. So we go offline, and then we can see that the star contactor must be the one to start the main contactor, not the star push button. So we change here to be the star contactor point, which is 5.4, and then we can take this out of circuit. Okay, so now we can then cross check to see whether this solves our problem. So we go online, we save our project, download, and then we can now put on the goggles once again. Okay, so with all the conditions met, now we will go back again and then start. So I press on the start. Okay, so immediately I press start. Okay, so now after the correction, we can now press again. So we can click on the, and then we can see, and then we can check our timer to see it's counting 3 seconds more. Bingo. So we can see that the delta has taken over. Star is out of circuit now, and then the main contactor is also running. Okay, so we will stop it and then we'll test it again. So remember, the start push button must always be push and then untick. Okay, so I'll go to stop, which is 3.5, and then we can see that the delta contactor has stopped. The main was also off. I'll start again. So this time let me push to the timer point so that we can see the timer counting, and then start. Okay, main contactor has picked, star contactor has picked, and then we can see the timer counting down. Okay, now it has changed over. Delta contactor is now picked alongside main contactor, and then we can see star contactor out of circuit. So we can see that our circuit is working perfectly. So now let's take for instance that we have a breaker tripping, which is 3.7. So we go to 3.7 and we can see that the whole process, we can see that now the process has stopped because the breaker has tripped. Okay, so this is basically how you implement star delta in step 7 in OB1. And we can see that from the beginning of our tutorials, we've been writing almost all our program in OB1. I think in the next section, we will look at how to organize a program, because basically writing all your program in OB1 is not advisable. So you need to create functions, and then you need to create FBs, which is functional block, to organize your program and also to make some of your code reusable. So in our next tutorial, we will look at how to create FBs and to make use of DBs to achieve programming purposes such as this. Okay, viewers, this brings us to the end of our fourth B part of our tutorial working with step 7. Kindly subscribe, like, and share our videos. Also leave comments down below so that I'll be able to understand some of the problems you are facing to better up this tutorial series. Thank you. Bye bye.